미티어의 김태정 대표님께서 열화상 카메라를 이용한 4차 산업혁명이라는 주제로 강의를 하면서 외국에서 또 이렇게 오셨어요. 미티어의 김태정 대표님을 앞으로 모시겠습니다. 여러분들 큰 박수로 맞이해주시기 바랍니다.
안녕하십니까. 미티어의 김태정입니다. 영상 카메라가 이제 산업군에 들어갈 때 어떤 식으로 결정을 하게 될지 저 위에 있는 그레이브라는 저희 회사 수석 엔지니어입니다. 저는 어느 방향으로 들어가는지를 설명을 좀 할 겁니다. 큰 박수로 맞이해주셨으면 좋겠습니다.
Okay, hopefully you'll all understand a little bit of English. What I'm going to try and do today is show you how thermal imaging can be used as a preventative maintenance tool. So if you don't understand English, please come and see us at the stand, but also hopefully all the pictures will help you see the images. We want to kind of support you in this area, so we have our distributor who's done the first presentation to help with you in the area. We've been manufacturing thermal cameras since, well, we've been doing it for about 25 years, and we've been in Ireland for 11 years. So again, the factory, as you can see. Again, at the factory, you can see production department, calibration. So again, we've got full production within the factory, and we have a European detector for all the cameras. The range of cameras, these predominantly are all the handheld units. And again, we're starting at a 160 by 120 resolution. We go 320, 240, 640, 480. So again, we have a whole range of different cameras for each application. A bit about myself. I've been in the industry for about 18 years. I started off with NEC as a European service engineer, and then I spent 6 years doing building surveys looking for problems. And then recently I've spent 6 years with Satir, helping them with product support and after sales. So again, you can see a whole range of different thermal images, from buildings to security to equine and even Top Gear race cars. This latest one, you can see where we've got gas coming out of a chimney stack. What we want to do now is really show you how a thermal image can help you as engineers diagnose the problem. Infrared energy is energy from any solid object which is emitted. So again, what the camera is doing is actually picking up that energy and putting it into a nice pictorial picture for yourselves to understand. So again, the next few slides will show you how easy it is to identify problem areas. And again, the infrared energy has been around since the 1800s when it was first discovered using sunlight and a prism. Most thermal cameras which we talk about will use a wavelength 8 to 14 microns. That is the standard kind of wavelength for most engineers. What's happening now is that the cost of the cameras are coming down and the detectors are coming down, so we are now looking at using different wavelengths for different applications. But again, as you can see, where the wavelength sits, there's your visual, there's infrared, so again, it is a different way of looking at problems. As with all engineers, what we would recommend is a variety of different tools. Most engineers need to know about vibration, ultrasound, acoustics, infrared, oil lubrication analysis. So all those are tools to help diagnose problems. But what we want to do is try to concentrate on the infrared for this next few slides. As we said, infrared is very easy to actually diagnose problems, and it will help you prevent forced shutdowns. Condition-based monitoring, we normally say what we normally say in condition-based monitoring, what you need to do is save your company any losses. So again, it's forced shutdowns. So again, if we can pick the problem up earlier, we'll stop the problems. What the insurance companies have come back with, they've said in 9 years, it cost the insurance company $1 billion in failure at the company plant. So again, this is why we want to get the maintenance done properly. They've also said that every $4 to $6 is saved for every $1 invested in capital equipment. So again, it's a long-term strategy for the company. In the US, they said that the $80 billion was lost due to power disruption. So again, what we're trying to do is say to you, this is what's going to cost. It's going to cost the company money, but also your clients. Okay, this is really what you want to see, is thermal images in action. So again, you can see here, electrical problems, all connectors, all having problems. And this is how easy it is with the thermal camera. If we get the camera in the right position, you can see all these problems. So again, this is what we want to try and show you, how to use the camera and get the best. With mechanical, we've got issues with connections. Again, very clearly you can see where the problems are. And this is where we would help with training as well for you to use the camera. What we can do is look at transformers. So again, we'll start to look at the connectors at the top for any problems in connection or arcing. And then we may look at the levels of the fluid to make sure that there's no fluid escaping. So again, one image can do several different jobs. Electrical panels. We can't normally see behind the panels, but again, thermal imaging very clearly can indicate there's an issue within that panel. Once you've found an issue, you can then either open up the cabinet or shut down and open up, but your precautions are there because of the high voltage and the high temperatures. So again, it is worth using a camera for these areas. Some more electrical problems, very easy to see where the problem is. So again, using the camera, you can find problems and help do the maintenance and do preventative maintenance. With this one here, we're looking at the heat sinks on the motors, but also the bearings. You can see that the bearings are getting warm. So it could be misalignment. So again, maintenance, something can help you with. With a bearing being misaligned, you get more friction, but you may hear some sounds with the ultrasound and acoustics. So again, using different tools. Blockages in pipework. So again, is that blockage due to sediment, or is it the insulation failing within the pipework? Very difficult to understand, but we know there's a problem. On here, we're looking at the valve, and it's not letting any heat through, so we know the valve is functioning correctly. In the UK, we use a lot of underfloor heating. So again, we're looking for underfloor heating and problems. And again, the cameras are very useful for this application. Visually, I cannot see a problem, but thermally, I can now see the problem. We have excavated, and then you can see the small amount of water escaping. So again, with the small amount of water escaping, we can repair. So that's how easy it is to use the cameras. Building structures, we're looking for moisture within the building, cold air entering, and rainwater. So again, all these things can be used for different applications. One camera can be electrical, mechanical, building. So it's a very good tool for all the engineers. One of the new areas is solar panels. So again, what we're doing is inspecting the solar panels during the day, and clearly you can see the cells which are starting to fail. And this is from the front of the panels or from the rear. So again, it's very easy to see. Once we've found the area, we can then decide when we replace the panel. And that's the nice thing, we decide when we do it. If the panels fail and continually to fail, they will, instead of giving you energy, they will draw energy. So again, it's useful to keep an eye on the maintenance of the solar panels. Fever detection, again, used in the airports. So again, we're identifying people with high temperatures. So if you come into an airport and you see a camera, they're looking for someone with a high temperature. Once they've found somebody, they will escort them and do further tests. Again, what we're trying to do is reduce the downtime of the factory, increase the operation effectiveness of the factory and the equipment, reduce the risk of expensive reactive maintenance, increase the life of the equipment and improve customer service. So again, all these are a benefit to the factory, and it's your knowledge as engineers and technique to help save the factory some money. Just a very quick one on the steel plants. If you actually look in this area, you have the top 4 of the top 6 steel plants. So again, we'll look at the steel plants and see how we can use a thermal camera to save you money. So again, we could look at in production, so you can see if the steel's coming out and we've got an even temperature. So we're looking for a nice even temperature of the steel as it comes out of the furnace. So again, if it's a nice temperature, we haven't got a problem. If we then start looking, you can actually see where there's a problem. If you look at the 3 slides, you can see where there's impurities within the steel because they're coming to the surface, and very easily you can see it with a thermal camera. Because it's steel, it's very hot, it's very difficult to see with the human eye, but with a thermal camera, clearly you can see the problems. And again, we can use it around the site when they're actually pouring steel, seeing if it's all okay, seeing levels, and again, different levels in the outside of the industry. So again, using the thermal camera, very useful tool. This one here, we're looking at the steel as it comes out of the oven, and again, we're looking for impurities, but we can also see how it's starting to cool down as it's coming out of the oven. So again, we're making sure the process is correct. Looking in the railway and mining industry, so again, we're looking at electrical and mechanical problems, clearly see. But again, because it's in the mining, the lighting isn't very good, but a thermal camera doesn't need light. So again, very useful. Bearings, electrical connections, looking at the drill head and the face of the coal using the thermal camera. So again, different techniques to give improved versions of how we can monitor the production line. Again, very simple one. Bearings. A bearing is going to cost you about $5. But if that bearing fails, it may cost you thousands of dollars in production, lost time because the conveyor belt has failed. Looking thermally, you can identify which bearing has got warm and is going to fail. So again, useful tool. Also on the railways, we're using the thermal camera for looking for trackside problems, but also we're also looking for people entering the railway who shouldn't be there. So again, now looking towards maintenance, but also security. Yeah, that's right.
I can run.
Yeah, just there you should be able to video. We're looking at trams, and again, we're looking for connections. Again, we're looking for anything where there's some form of friction or arcing. So again, thermal camera is very good for this type of application. So you can see the problems. We'll quickly talk about Sellafield. They had a problem in 2005. So again, the next slide. They lost 20 tons of uranium. It leaked and they couldn't find it. The plant, it was classed as a level 3 incident, which is a serious incident. And what they actually traced the leak to was a cracked pipe only a few centimetres wide. Could the thermal camera have picked that up if the maintenance was done properly? There's a strong possibility it could. So again, we could have saved an awful lot of money and problems to the environment if we got the maintenance schedule correct. So again, you can see we're looking for problems in pipe work. Thermally, we can see there's something going on. If we know as engineers there's a problem, we can then go and investigate and do some other tests. But if we don't look visually, we're not going to find out. Fire detection, again, using a thermal camera. We're now looking for increasing heat in the environment, in the woodlands. So again, we're looking for problems, and thermally, we can pick it up. We can monitor 24 hours a day, 7 days a week, day and night. So again, it helps the environment. What's happening now? Most people use thermal cameras for electrical and mechanical. We're now using it for looking for air purities and escape of gases. So again, we're looking for SF6 or benzene. They're some of the chemicals which we'll be looking for an escape of gas. Again, I'm not going to go too much into the FF6, but again, we're normally looking for problems around these areas for where the gas is escaping. You can actually see just there, just see if we can get the video to work, but you can actually see the gas escaping from that point just there. Okay. Just go to the bottom of the picture. Okay, try again. So again, this is from a chimney stack, and again, you can see the gas escaping. Now this is about 20, 30 metres away. So again, the old-fashioned way would be with a sniffer, and you have to get above the gas. With a thermal camera, we can do it from below and from distance, so we're a long way away, and it's healthy for us as engineers. So again, very simple to see. You can see where the problems are. What we're actually looking at now is thermal cameras. In 1995, you were going to be spending $30,000 plus to buy a camera, as you can see. But what you're actually getting now below $2,000. So technology is moving on, and we as a manufacturer want engineers to come to us and find out and tell us what type of cameras you want to move on. But as you can see, look at the size of the camera, now look at the size. The processing power of that camera was very poor. Nowadays, you've got a processing power very, very good. This unit here is an Android-based system, so it's not just a thermal camera, it can hold data, storage, images, everything. The old-fashioned one would just give you an image. So again, technology is moving on, and this is where we are within the company. Where we are going to go next, we're not sure. Again, look at the size of the camera. Nice and big. That was really good at the time. But now, it has to be that size or smaller. So again, technology is moving on. Where will it be in another 20 years? We're not sure. But this is how technology moves. From a nice big unit to small. So again, we'll see where it goes in the future. To summarise, maintenance is made easier using infrared cameras. A picture or a video says 1,000 words. So again, use a picture, it's very nice to do diagnostics. Infrared can help you as an engineer and see problems which the human eye cannot see. We can inspect 24 hours, 7 days a week on fixed cameras. So again, you don't have to be there all the time. Correct interpretation of the image can highlight the potential problems. One key thing we would say is training and understanding the cameras is very important, and that is one thing we want to work with our distributor in, is getting him to give you training and understanding of the image. Once you understand that, you will be very good at interpreting it, and it will help you in the future when you're doing your diagnostics. I'll just pass you back on to our distributor and he'll be able to finish off. But if you have any questions, please ask him, and if he has to, he can interpret, and we can hopefully get a good answer.